dy dx plus 1 over x times y equals 3xy squared. So let's make the substitution then according to Bernoulli's equation. Let v equals y to the 1 minus n. Everything's arranged in the correct order. So the n value is this. So it's 1 minus 2, which equals y to the minus 1, or 1 over y we could say. So let's get dv dx then. dv dx equals, that's y to the 1, so it'll be minus 1 over y squared multiplied by the something differentiated. Function of function rolled something is y in this case. So there's dv dx. Rearrange it for dy dx then. Equals, the minus can go over there and the y squared can go up with it. So we'll get minus y squared dv dx. There we go. So now let's make the substitution then. So substituting, subs gives. So the first thing, dy dx, let's put this in here. So minus y squared dv dx plus 1 over x times y, let's worry about that term in a minute, equals 3xy squared. Now we can divide by y squared all the way through, and let's see what we get. So divide by y squared then, and that makes this disappear. I'm going to divide by minus y squared so the minus can go at the same time. So we'll get dv dx, and this becomes a minus, doesn't it? Divide by y squared, so we'll just get 1 over x times the 1 over y. Now the 1 over y is the value of v, so I'll put that in there, equals 3x times minus y squared. Divide by minus y squared is a minus, isn't it, there? So that looks good. So now that's just our normal integrating factor method that needs to be employed here. So here, the integrating factor then is equal to e to the integral p dx. Let's just circle the value of p because everything's in standard form. There it is there. So let's write it down then. Integral p is minus 1 over x dx. And that's minus log, isn't it? So it's e to the minus ln x, which equals e to the ln of x to the minus 1. And these cancel each other out now, because one is the inverse of the other, so to speak. So we end up with x to the minus 1. So this is what we multiply them by. So what do we get then? Multiplied by x to the minus 1, we get 1 over x dv dx minus 1 over x squared times v equals minus 3, isn't it? When you times x, that x will cancel the 1 over x that you've timesed it by. So we get this, and now we can circle u and v. So it should be fairly straightforward from here. There's u, there's v. So we can write down d by dx of uv of u times v, 1 over x times v, v, close bracket, equals minus 3. Integrate both sides. So here's our problem now. Integrating gives, so the integral of the left will be just what's inside, 1 over x times v, equals the integral of minus 3 dx, which equals minus 3x plus k. Now v is 1 over y, wasn't it, in our original substitution, so we can put that in now. So 1 over x y is equal to k, I'll write that first, minus 3x. Invert both sides. So the inverse, the fraction upside down on this side is equal to the fraction upside down on this side. So it'll be 1 over k minus 3x. And then finally then we can get y. So move the x from times on one side to divide on the other. And we get 1 over x bracket k minus 3x. More than one term underneath, put a bracket. So there's a bracket around this, so that when you move this, you can move it to times underneath. Okay, there we are.